So this is the the lecture for section 7.5, MIC 2233, Applied Calculus. So this is the last section for the course. And so here what we're finding is the area between curves. So to begin with, we can just introduce this for a little, just briefly, and then kind of get into some examples. But we have two functions, f and g. They're continuous. F of x is greater than or equal to g of x on an interval AB. Then the area between the curves of f of x and g of x from a value of x is equal to a to x is equal to b is given by the integral of f of x minus g of x dx from a to b. So what that can look like here, I'm going to put this one here as y just for the sake of argument. So if I have f of x, right, I'm going to make this a, I'm going to make this b. So this is my function f of x. And then let's say that this is my function g of x, right? So what we're looking for then is the area between the curves and the interval that's given. So this shaded region right here would be what we're looking for. And we can use just the integral of the difference of the functions between those. So normally what they do is they define some restrictions. In this case would be a and b, the interval, and we're just looking for those. Now again, when they say that f of x is greater than or equal to g of x, what they're saying is that at every point, especially between a and b, the function f of x is obviously greater than the function g of x between those intervals, and that's what that means. The next thing is consumer surplus. So if d of q is a demand function with equilibrium price p of 0 and equilibrium demand q of 0, then the consumer surplus is the integral of d of q minus the price function, d of q from 0 to the equilibrium demand quantity. Now the producer's surplus is if S of q is a supply function, again with equilibrium price P0 and equilibrium supply Q0, then the function of the integral would be the price function minus the supply function D of q from 0 to Q0. So looking at number one, we're just going to find the area between the function that's given, the curve right here. Y is equal to 2x squared plus 5. The a and the b is going to be negative 2 and 1. And then y is equal to 0 is just basically defines that it's going to be above the x. So the way that looks here, it looks something like this, right? So the blue line is the function 2x squared plus 5. We have the vertical line, x is equal to negative 2, which is the red. The orange is x is equal to 1. So this shaded region here is what we're going to find the area of. And of course, the x is just the y is equal to 0 line. So that's what we're going to find. We're going to use, oops, that's not what I wanted. There you go. We're going to go ahead and find that area. So when we look at this, what we're going to do, let me go back to the black here real quick, is the integral between negative 2 and 1 of 2x squared plus 5 minus 0, which is the other function. Let me just rewrite this here real quick. So in this case, your f of x would be your 2x squared plus 5, and then your g of x will just be 0, right? And so that's why we do that. And of course, it's going to be, so now when we find it, it's going to be the following, right? So it's going to be here 2x to the third over 3 plus 5x from negative 2 to 1, excuse me, which is then is going to be 2 over 3 plus 5 minus negative 16 over 3 minus 0, which is going to be equal to 21. So we saw that in GeoGebra here, that the area is equal to 21. So that's how you do number one. So the next one that we're going to do, let me go back here, is number 3. And so number 3, we have the following. And again, I'm gonna go ahead and draw it out. So x is equal to -3. X is equal to 1. Make sure I write the right function. Y is equal to x to the third plus 1, and y is equal to 0. So then if I go back here, so just to show you what that's going to look like, we're going to go ahead and I'm going to go to GeoGebra, get rid of all of these. And so I'm going to find the integral of x to the third plus 1. Oops, no, that's not what I want. Okay, hold on a second. Let me make sure that I have this. Okay, plus 1. And then it's going to be from -3 to 1. And so this is what it's going to look like. The integral of this particular problem. And so what's going to happen here is that we have several things that we're going to look at. So the first one is we're going to find the points of intersection for this particular function, right? So when does x to the third power plus 1 is equal to 0? We're going to set the two functions equal to each other, and we get that x is equal to -1, right? And so the region is composed of two separate regions because y is equal to x to the third plus 1 intersects y is equal to 0 when x is equal to -1. So what we're going to do is we're going to let f of x equal to x to the third plus 1. We're going to say that g of x is equal to 0, basically what I sort of had said before. Now the first interval here between -3 and 1, g of x is greater than f of x. And then for the second interval, between -1 and 1, f of x is actually greater than or equal to f of x. Right, if I go back to GeoGebra, you can see here that from -3 to -1, g of x is greater, and then from -1 to 1, f of x is greater, right? And so that's what this is explaining. So then we're going to have basically here from -3, there should be a -1, to -1, it's going to be g of x minus f of x dx, right? And it's going to be plus, and then here's going to be -1 to 1 of f of x minus g of x dx, right? So that's what we're going to find. So when we do that here, what we're going to end up with is the following. So the integral of -3 to 1 of 0 minus x to the third plus 1 dx plus -1, 1 of x to the third plus 1 minus 0 dx, right? So those are the functions. And so when we calculate these, we're going to end up with, we'll put it here, with x to the fourth over 4 minus x from -3 to -1, sorry, plus, here we're going to have x to the fourth over 4 plus x from -1 to 1. And so when we evaluate this, we're going to have -1/4 plus 1 minus -81 over 4 plus 3 plus 1/4 plus 1 minus 1/4 minus 1. And so that's just going to be equal to 20 when we evaluate everything. So the reason we created these intervals is because the function g of x is greater than f of x between -3 and -1. And then f of x is greater than or equal to g of x between -1 and 1. So then you have those two parts that you have to do. All right, let's go to number 8. And so let me just write number 8 here. And this one, so number 8, y is equal to x squared minus 18. And then y is equal to x minus 6. And so going back here to GeoGebra to kind of write these out, let me get rid of this. And so what we're going to find is the integral of, in this case, I'm going to have two functions. So I'm going to have, the first one is x squared. I'm just writing it here real quick, minus 18. And then this one is going to be, sorry, let me do this. Oh. Let me do this again. So this is going to be x squared minus 18 for this particular one, minus, and then so in this case it's going to be the other function, which is x minus 6. And basically it's just going to be, since these two functions intersect at -3 and 4, so it's going to be -3 comma 4. And I'll show you why that's the case here in a moment. Why do they intersect at that particular point? So let me go back here and make sure I put my parentheses. There you go. That's what I want to do. Yep. Took it off again. And then put one here so I can have that. All right, and so this is the area. Now, x minus 6, of course, is going to be a line, and then we're looking where they intersect. And so what we're going to do here is if I set them equal to each other, and this is where we ended up with the answer that we did. So x minus is equal to 0, which means that x minus 4 and x plus 3 is equal to 0. So where do they intersect? When x is equal to 4 and x is equal to -3. And so here we're going to have the integral of -3, 4, x minus 6 minus x squared minus 18 dx, which then is going to be the integral of -3, 4 between x minus 6 minus x squared plus 18 dx, which again is the integral from -3 to 4 of -x squared plus x plus 12 dx, which is just going to give us -x to the third over 3 plus x squared over 2 plus 12x from -3 to 4. And so just for the sake of time, when you evaluate that, it's going to be 57.167, just like we got in GeoGebra here just a moment ago. So the next one, I'm going to skip over to number 27 real quick. And so number 27, we're going to talk about surpluses, right? So it says, suppose a company wants to introduce a new machine that will produce a rate of annual savings in dollars is given by S prime of t is equal to 150 minus t squared, where t is the number of years of operation of the machine while producing a rate of annual cost of dollars of C prime of t is equal to t squared plus 11 over 4t. And so for part A, it's asking us for how many years will it be profitable to use the new machine, right? So we look at number 27, and so we're basically going to find the integral here to see where is this particular usage is going to be profitable. So the first thing is we're going to set s prime of t equal to c prime of t. So in other words, 150 minus t squared is equal to t squared plus 11 over 4t. And so here, if I move it over to this side, it's going to be 2t squared, right? Plus 11 over 4t minus 150. And so what we have here, we can get rid of the fraction. So we're going to multiply everything by 4. So it's going to be 8t squared plus 11t minus 600. So we're going to have to use the quadratic formula where t is equal to negative 11 plus or minus 11 squared minus 4 times 8 times negative 600 over 2 times 8, which is going to be negative 11 plus or minus 139. Sorry, let me rewrite that. Over 16. And then when we do that, we get t is equal to 8, or t is equal to negative 9.375. So then the negative we can ignore, so this will be profitable for 8 years. Now, looking at part B, for part B for this one, it says, what is the net total savings during the first year of use of the machine? And so, since the function 150 minus t squared is greater than t squared plus 11 over 4t, in the interval from 0 to 8, so the net total savings for the first year of the usage of this machine is just going to be the following. So the integral from 0 to 1, a 150 minus t squared minus t squared, right, dt. And so that's just going to be the integral of 0 to 1 of negative 2t squared minus 11 over 4t plus 150. Just combining like terms here. dt, which is going to give us negative 2t to the third over 3 minus 11t squared over 8 plus 150t from 0 to 1. And so when we do that, we get approximately 148 dollars in this case. So part C, it says the net, for part C it says what are the net total savings over the entire period of the use of the machine. So then at this point in time, we're going to go from 0 to 8. All right, so we're going to go from 0 to 8 of basically the same. So it's going to be 150 minus t squared minus t squared 11 over t dt, which is going to be the same thing that we got the previous answer, right? It's going to be 2t to the third over 3 minus 11t squared over 8 plus 150t from 0 to 8, which is going to be 771. So the savings is going to be $771. So that's how we do 27. Let's move over to number 31. So number 31, it says that the producer surplus. So find the producer surplus. If the supply function for pork bellies, number 31, is given in dollars by, so S of Q is equal to 100 plus 3Q raised to the 3 halves plus Q raised to the 5 halves. Now, assume supply and demand are equilibrium when Q is equal to 16, right? And so the producer surplus is equal to the integral of the price function minus the supply function from 0 to the equilibrium quantity. And so now to find P of 0 is just C of 16, S of 16, sorry, which is 1,202. So the producer surplus then becomes the integral from 0 to 16, right? Price function is 1,202. And then this is Q to the 5 halves plus 2Q raised to the 3 halves plus 50 dq. And so we kind of clean it up a little bit. I'm going to get 1152 minus Q raised to the 5 halves minus 2Q raised to the 3 halves dq. And so when we finish it, it's going to be 1,152 Q minus 2 over 7 Q, using just the power rule here. Q raised to the 7 over 2 minus 4 over 5 Q raised to the 5 over 2 between 0 and 16. So then this is just going to be, since it's 0, we're not even going to evaluate that. So it's going to be 1,152 times 16 minus 2 over 7, 16 raised to the 5 halves minus 4 over 5, 16 raised to the, 7 halves. To the 5 over 2. Which ends up being 12,931.66. So the producer surplus for this particular problem is $12,931.66. So the next one is number 33. Is consumer surplus. So it says, find the consumer surplus if the demand function for grass seed is given in dollars by D of Q is equal to 200 over 3Q plus 1 squared. Now, assuming supply and demand are at equilibrium when Q is equal to 3. Now, just real quick, equilibrium basically means, that the quantity here is equal to 3, right? Okay. So, actually, no, I was right the first time. Sorry about that. Let me do this again. Right. Okay. So for this particular one, for number 33, we're going to do the same thing. So just remember that consumers surplus is equal to the integral of 0 to the equilibrium quantity minus the price dq, and then P of 0 is equal to D of 3, which is equal to 2. So the consumer surplus then becomes the integral from 0 to 3 of 200 over 3Q plus 1 squared minus 2, right? dq, because that's what we're doing here. And so this just becomes the integral from 0 to 3 of 200 over 3Q plus 1 to the second power minus the integral of from 0 to 3 of 2 dq. So here what we're going to do is we're going to let I'm going to do some substitution. Oops, sorry. I'm going to let u equals 3q plus 1. So du is equal to 3 dq. And then 1/3 du is equal to dq. Right? And so the original one is going to be 1/3. Now, of course, we're going to have to change the values, right? So when q is equal to 3, this is going to be 10. And so it's going to be from, basically from, and then, of course, when u is equal to 3 times 0 plus 1, I get 1. That's where the 1 and the 10 comes from. So then this is going to be 200 over u squared du minus 0, 3 of 2 dq. So the 2 doesn't change. So then this is going to be 200 over 3 of 1 to 10 of u raised to the negative 2 minus 0, 3, 2q, right? And then, so this is, of course, going to be 200 over 3 times u over negative 2 raised to the negative 1 over 1 from negative 1 from 1 to 10 minus 2q from 0 to 3. And so for this particular one here is when we kind of wrap it up is going to end up being 54. So $54 is the what's this number, 33, so that'd be consumer surplus. All right, and I'm going to leave 35 for you guys. Do not graph. And then so just go ahead and do B, C, and D. So B through D. And that's the end of 7.5. Thank you.